Next, we are going to start our next section. And here, in the last session, we discussed about human eye. And in that session, already many times I gave you a sentence, or I explained with a sentence like this. For a normal eye, image we are getting on the retina. So it's sure it is for the normal eye, images on the retina. Now special cases will be also there, which means if some defect is there for the eye, instead of on the retina, we will get image at some other places. Okay, so they are called the defects of vision. So now in today's class we are going to study what are the defects, main defects of vision. Okay, now first we are discussing mainly for the most of the children, we are seeing this defect, which is what? Short-sightedness. Okay, so we are studying the first defect of the human eye, which is short sight. And the another name for the short sight is myopia. Okay, short sight, which is myopia. And before getting to the topic, I wish to give you I wish to explain two terms related to this. First is near point. Near point means it is the minimum distance we need to keep with the eye in order to get the clear vision. Okay, and if now for a normal eye, the near point is 25 centimeter, in which means if you are keeping a book near to us 25 centimeter, if you are keeping not only book, whatever it is, okay, if you are keeping something at 25 centimeter, we can see it clearly. But if you are decreasing the distance, what will happen? Our vision will be blurred. Okay, that is what the near point. Near point means the minimum distance we need to keep with the eye in order to get the clear vision. Now what is far point? Far point means for a normal eye, from the infinity, from a far away place to we will get the clear vision. Okay, so for a far point for a normal eye is infinity, which means we can keep materials, or we can keep anything for if it is at infinity, distance infinity to, we will get the clear vision. That is what the far point. Okay, near point means the minimum distance we need to keep. Far point is maximum distance, up to infinity we can keep, and we will get the clear vision if we are keeping something at infinity. Okay, now usually short-sightedness are very familiar nowadays, especially for the children. So for a short-sighted eye, or for a myopic eye, we can say those person can see the nearby object. Is it possible for a short-sighted person to see nearby object, but he is unable to see a distant object? Okay, if you're keeping very far away, it's for a myopic eye, he will be, or he or she will be unable to see that. Okay, but if you're keeping nearby objects nearby, he or she can see that, see it clearly. Which means only for a myopic eye, only the problem in the far point of a object. Okay, for the near point, for if of myopic eye, for near point will be over. Okay, if a light is coming from a near point or the near object, he can see it clearly, means that he have the problem only with the far point. Okay, far point means we are keeping the object, or we are looking at a distant object. Okay, in those cases only, for a short-sighted eye or short-sighted person have the problem. Okay, so the diagram, this is what the ray diagram for the myopic eye. It's very important, you have to study. Okay, how to draw. So for the near point means the light is coming from a near object. Okay, so in such cases what happen? The light through the lens, it reaches the retina. So no problem for that eye. If the image we are getting on the retina, no problem. Okay. So for the near point, for a myopic person, if the light is coming from a nearby object, we will get the image on the retina without any problem. Okay. Now we already discussed only for the myopic eye, only the problem with the far point, which is if a light is coming from a far away place, he or she can't be able to see. Okay, so what will happen if a light coming from a far away object? What is happening there? This is what the retina. From the figure itself, it's clear. We are not getting the image on the retina here. Here is a place of retina. Here, because of the near point, image is getting on the retina for a myopic eye. But if for a object or a light is coming from a far away object, so image is not on the retina. Where it is the object we are getting? Image is getting instead of retina, image is getting in front of the retina. That is what the problem. For a myopic eye, if light is coming from a far away object, instead of on the retina, image is getting in front of the retina. Okay. Now, maybe what all reason for the short-sightedness? Short-sightedness mainly because of two reasons. First is elongated eyeball. Eyeball means this is in the form of a ball. So we are calling it as eyeball. And this eyeball, ball-like shape sometimes get elongated. So in front, instead of on the retina, sometimes we are getting, if the light is coming from a far away object, that is far point, we are getting the image instead of on the retina, will be the in front of the retina. And focal length of the lens is short. That is what the second. The lens have the shorter focal length. That is also the second reason. So the causes is elongated eyeball and the focal length of the lens is short. Now we are using spectacles. For a myopic person, we can correct. We are using lens. We are using spectacles for the correction. Which lenses are using for those spectacles? We are using for a myopic eye. We are using concave lens for its correction. So if you are using concave lens, what will happen? We want to make the image on the retina. Then only we can say it's a normal eye and our vision will be clear. So if we are using a concave lens on the path, if you are looking at a far object, and in the path if you are using a concave lens, that is our spectacle, or a spectacle made by concave lens, what will happen? Instead of in front of the retina, like a normal eye, we will get the image on the retina. Okay, റെറ്റിനയുടെ മുന്നിലാണ് മയോപ്പിക് പേഴ്സൻ്റെ ഫാർ പോയിന്റ് ഉണ്ടാവുക. If we are using the concave lens, instead of in front of the retina, we will get the image on the retina. So it will function like a normal eye. Okay, so you have to prepare for an essay, defects of vision. First we discuss the first defect, which is myopia, defect of human eye, which is hypermetropia. The another name for hypermetropia is Lawson. Here it is just a reverse of what we discussed earlier. That is just a reverse of myopia. This one, the hypermetropia. Okay, now reverse means I already mentioned for a myopic eye, he or she can see the nearby object, but he is unable to see the distant object. But in the case of a hypermetropia, he can see distant object, but he will be unable to see the nearby object. This nearby and this distant, I just make an underline. We need to specify it. We need to specify the distance here. So we can say that he cannot see the substance or materials if we are keeping those materials at a distance less or equal to 25 centimeter. Okay, so for a hypermetropic eye, he or she will be unable to see the object if you are keeping at a distance less than or equal to 25 centimeter. Okay, if you are keeping a distance of 25 centimeter or less than 25 centimeter, myopic eye can't see. So he will be able to see if you are keeping a object greater than 25 centimeter. So greater than 25 centimeter is a distant object, and less than or equal to 25 centimeter is a nearby object. So if you are keeping a object which is at a distance greater than 25 centimeter, it's not problem for a hypermetropic eye. He can see it clearly. Okay, but only if you're keeping, for a hypermetropic eye, if you're keeping the object at a distance of which is less than or equal to 25 centimeter, for those persons or those objects will be unable to see for a hypermetropic person. Okay, so only the problem if you're keeping a object which is less than or equal to 25 centimeter. So what will happen if you're keeping an object at 25 centimeter near to our eyes? What will happen? From this figure itself it's clear. If you're keeping object at 25 centimeter or less than 25 centimeter, here the retina, instead of on the retina, we are getting the image behind the retina. Okay, in the case of myopic eye, we are getting the image in front of the retina. Here we are getting the image behind the retina. Okay, now how we can correct likewise what we did in myopic eye, correction also possible for a hypermetropic eye. So here we can correct a hypermetropic eye with the help of a convex lens. If you're keeping a convex lens in between, instead of behind the retina, we will get the image on the retina. Okay, now causes is just the reverse of what we discussed earlier. Cause will be because of small ear ball or focal length of the lens is large. So two causes for the hypermetropic eye. Here I want to discuss one more defect, which is presbyopia. Presbyopia is same that of hypermetropia, because which is he can see the distant object, he cannot see the nearby object. But the cause for the presbyopia is different. The cause for the presbyopia is somewhat like this. It is due to the stiffening of ciliary muscle. This presbyopia happens. Okay, ciliary muscle, that contraction and relaxation process somewhat have some problem. Then a defect called presbyopia will happen. Okay, so we discussed three defects: myopia, hypermetropia and presbyopia. Myopia and hypermetropia is just reverse. Okay, reverse to each other. Thank you.